Okay, so we're into section 3.2, which is truth tables and equivalent statements. So we're going to start out like we usually do. We start out with problem number 1. And it says, use the concepts introduced in this section to answer exercises 1 through 6. If Q is false, then what must be the truth value of the statement? P and not Q, and then and Q. Okay, so what we do is we look at the truth table for this question, and we're assuming that if this is false, so I guess it probably doesn't matter what P is. So let's think about that. Let's just, so if P, we have P and we have Q. And Q is false. Okay, so we're going to go with the false statement. So let's say P can be either true or false, and so not Q is going to be true in the same way here. If this is false, and not Q is true. Okay, so then we do the next one, which is P and not Q. And for this to be true, both of them have to be true. So we get true and true, which is true. And here we get false and true, which is false. So again, both when you have an and, they both have to be true. And the final thing we do is we look at the last statement, which is this, P and not Q, and then and Q. And because Q is always false, then since this is false all the time, we never can get true and true, and that's why in this particular case the answer is false, that it always results in a false. And that's kind of the key thing here. It doesn't really matter what this is. When we do and false, if this is false all the time, then it's not going to work out. Okay, so number 4 says, if the statement P or Q is false, and P is false, then Q must be, so we're saying P is false. Then we must, what was it saying? It says Q, then Q must be something. Okay, so for something to be false with an or statement like this, they both have to be false. So let's just do this here, P, Q. So if this is false, and this is false, and we want to do P or Q, and if this is false, and this is false also, the question is, what does Q have to be? Make sure I'm doing this right here. Okay, so you have to have 2 falses to get a false. So if this were true, then it would end up being true. But in this case, they both have to be false with an or statement. So that's the result is that Q must be false. Because if it wasn't, if we had true here, you get a true or false. An or statement means you get a true. Okay, what do we get next here? 7. So it says, let P represent a false statement, and let Q represent a true statement. Find the truth value of the given compound statement. So not P, and P is false. We don't have to worry about Q because it's not involved. So if P is false, then not P is true. Okay, so either has to be true or false. It can't be something in between. Okay, number 10, P and Q. So again, P is false, And we could probably stop there. If either one of these is false, then it's going to be false. So, and Q is true. So again, both these would have to be true to the compound statement to be true. So this is going to be false. Number 13, not P or not Q. So P is false, so not P is true. And not Q is false because Q is true. So this is an OR statement, so it just means one of these two has to be true for the thing to be true. So since one of them is true, with the OR statement, the answer is true. Okay, 16. Not P or not Q. Okay, so P is true. Is that right? No, P is false. So P is false. Q is true. Therefore, not P is true, and not Q is false. So if we do this thing here, it's a union. So a union of these two here, only one of them has to be true. So since it's an OR statement, we know that not P or not Q, we know that's going to be true because this one's true and this one's false. So one of them's true, so it's true. And then we do the negative of this. If you do negation of that, because this was true, then the negation of that is going to be false. So 16 is false. Okay, number 19. It says, why is this statement true? 8 is greater than or equal to 3. So why is the statement 8 greater than true? So okay, it's interesting. I'm just looking at the answer. It's right in the book. It says 8 is greater than 3 is true because 8 is greater than 3 is true. So I'm not quite sure what that means. Okay. Oh well. Let's go to 2021. Let P represent a true statement and Q and R represent false statements. So P is true, Q is false, R is false. And it says find the truth value of the given compound statement. So what we do is we take the inner term, P and R. So these both have to be true to be true. So P is true, R is false. So this is false because it's an and. If it was an and these were both true, then it would be true. So out of the 4 possibilities, only one is true. And then what we do is we take this, which is false. So we have something false that is in union with something that is not Q. Okay, what's not Q? Not Q is, since Q is false, that's true. And so we have something false in union with something that's true. And the only time this is false is if they're both false. And since one's true, the whole thing is true. Okay, 24. We have not P intersected with Q in union with not R. So again, not P is, well, P is true, so not P is false. Q is false. So if we do this not P intersected with Q, because they're both false, because one is false, you have to have both true to be true. Other all combinations are false. So this is going to be false. So then we'll have false in union with not R. R was false. So not R is true. So false in union with true results in true, because we only have to have one true for both trues to get true. So that's 24. And we'll do one more here in this set. 27. Not P in intersection with Q in union with R. Okay, again, P is true, Q is false, R is false. So not P is false. So if we do this first one, we know that not P intersected with Q, not P is false, intersected with Q, which is false. So that gives us false. We only need one of those to be false. Okay, so then we go up here, we have false in union with R, which is false. And the only time you have a union where you don't get false is, we don't get true is if they're both false. So in this case, this is the one case and it's false. And then finally, we take the negation of that, the negation of this false, which is true. And so the final answer is true. Okay, so we're going to stop there for that one.